What if an interstellar object whirling through our solar system is actually a nuclear-powered spacecraft sent by aliens to test how humans respond?
From the darkness between stars, a stranger has entered our solar system, moving at 200,000 kilometers per hour, faster than any spacecraft humanity has ever built. It shines 10 times brighter than its size should allow, as if it carries a secret light no comet should possess. Its orbit is reversed, perfectly aligned with the plane of our planets, a path so statistically rare the odds are less than 1 in 1,000. And its journey bends it toward Mars, the hidden side of the Sun, and Jupiter, as if tracing a deliberate route across the cosmic stage. Astronomers see frozen minerals and pristine ice, but also silence where gas and dust should roar. Some call it coincidence. Others whisper probe, a machine disguised as stone. If true, this is the moment humanity has waited for, the first visitor not of nature, but of intention. Prepare for a journey into the mystery of 3I Atlas and the possibility that we are not alone. We begin. The night of discovery began like so many others, with a telescope in Chile scanning the sky for subtle motions that betray hidden wanderers. But on July 1st, 2025, the Asteroid Terrestrial Impact Last Alert System, ATLAS, caught something that did not belong. A faint streak, angled against the tide of familiar orbits, surged across the frame. At first, it seemed like another comet slipping through the black. Then, the calculations came. The speed was not ordinary. It was staggering. Over 200,000 kilometers every hour, a pace so immense it eclipsed the escape velocities of planets, shrugging off the sun's gravity like a loose tether cut in silence. Astronomers knew immediately that this was not native. Its path was not closed, not bound, not elliptical in the way of homegrown comets. It was open-ended, eccentricity greater than 1, the unmistakable fingerprint of an interstellar traveler, a fragment of some other system, some other star, now threading its way through ours. The designation arrived quickly. 3I Atlas, the third known visitor from beyond. The first was ʻOumuamua in 2017, the second, 2I Borisov in 2019. This was number 3, but already it was writing a different kind of story. Imagine looking into the night sky, believing the cosmos is static and predictable, and then watching a ghostly shape plunge into your neighborhood from the abyss. A stone or an emissary, no one could yet say. What shook scientists most was not simply the arrival, but the questions it stirred. How many of these wanderers roam unseen? Why this path, this speed, this moment? There is something cinematic in such discoveries. The sky split by a new line, the orbit plotted like a scar across the solar system's charts. Astronomers described the moment as one of electric unease, like hearing an unexpected knock at a door you thought was locked. We are not used to visitors from the galactic road. We live in a solar cul-de-sac, expecting long stretches of silence. Yet here it was, rushing in as though to remind us that the stars share their debris, their secrets, their shadows. Already whispers began. Could it be another comet, a frozen shard that slipped away from the violence of a forming star? Could it be a fragment cast loose by a dying sun, journeying for millions of years until it stumbled upon ours? These were the natural explanations, rational, rooted in what we know, but the anomalies piled quickly. Its brightness, for one, did not align with expectations, and its orbit, retrograde, sliding backwards against the direction of planets, grazed the ecliptic plane as if with purpose. Even at this first step, the sense of improbability hung heavy. The object was like a message scrawled in the dark, cryptic and swift. Some felt exhilaration, others felt dread. It was as though the universe had tugged aside a curtain, allowing us a glimpse of a script not meant for us. We stood in July 2025 as witnesses to something rare, perhaps unique. A visitor, yes, but also a mirror held to our own uncertainty. What do we know of the universe, truly, if such things can fall into our sky unannounced? What else drifts in the gulf between stars, unseen, unmeasured, waiting? And so began the vigil. Telescopes from Earth and orbit turned toward this faint traveler. The Hubble Space Telescope captured its glow, pinning its position like a lantern drifting across deep black. Infrared instruments probed for warmth, for spectral whispers of what minerals lay inside. Astronomers from continents apart coordinated, driven by urgency, because already 3I Atlas was moving on, never to return. Its trajectory guaranteed that this was a once-in-a-civilization chance. The object seemed almost indifferent to our gaze. No flare, no announcement, just a steady plunge into the inner system. Yet its very indifference magnified the strangeness. Here was an intruder that cared nothing for the worlds it brushed past, that carried secrets we could only glimpse through fragments of reflected light. In the days that followed, the name spread from research circles to headlines. A new interstellar object, another shard of elsewhere, and with it came the quiet tension that underlies every such discovery. What if it is not only rock and ice? What if there is intent behind its course? The story of 3I Atlas did not end at detection. In truth, that was only the prologue. Its strange brightness would soon unsettle expectations. Its impossible orbit would stretch probabilities to breaking, and whispers of alien technology would ripple through the halls of astronomy, daring to step beyond caution into wonder. But all of that lay ahead. For now, the first sighting lingers, a streak across a telescope's eye, a signature of another world rushing past ours, reminding us that the galaxy is wider, stranger, and more full of wanderers than we ever dreamed. The brightness of 3I Atlas was the first true riddle. A comet, even one from another star, should have behaved within known parameters. Its glow should have been dictated by size, distance, and the reflection of sunlight from dust and ice. But what astronomers saw in those earliest Hubble images unsettled them. The brightness profile was too steep, too intense for what the object's apparent size suggested. When you stand beneath a street lamp, the halo of light fades gradually outward, a soft gradient of brightness. A comet behaves the same way. Its central nucleus reflects sunlight most strongly, and that glow diffuses into a tail. Yet with 3I Atlas, the light fell off sharply, as though the source itself was compact, concentrated, a lantern hidden within. Calculations ran deep into the night. If the object were truly reflective, a mirror-smooth fragment catching the sun's fire, its dimensions would stretch 20 kilometers across, a mountain-sized interloper. But if it were self-luminous, glowing from within like a coal, its body would shrink dramatically, perhaps no more than a few hundred meters. That contradiction split the astronomical community. One path led toward a natural marvel, a reflective behemoth far larger than any previous interstellar visitor, luminous simply because of scale. The other path led somewhere stranger, a smaller body glowing of its own accord. But what natural mechanism could account for such self-illumination? Radioactive decay? Unlikely, given the sheer stability required. Internal heat? Perhaps. But even the largest icy bodies in our system bleed their warmth only faintly. Artificial light? The word lingered unspoken, then spread in cautious papers and whispered interviews. Could this be technology? The brightness paradox was not a novelty in itself. ʻOumuamua, the first interstellar visitor, had baffled astronomers with its Tumblin G-light curve, changing as if it were a flat, elongated shard flashing its sides toward Earth. 2I, Borisov, by contrast, behaved exactly as a comet should, gassing, brightening, and fading in line with expectations. But 3I Atlas was different. Its glow was sharper, more condensed, almost defiant of distance. To understand why this mattered, you must imagine the act of measurement itself. Telescopes do not see comets as solid objects. They see blurs of light. Every calculation, size, shape, distance, is reconstructed from brightness. It is as though you were standing on a dark shore, watching a lantern flicker across the sea, trying to deduce whether it is a candle or a lighthouse. With 3I Atlas, the flicker did not match the seas we knew. Skeptics pointed to dust. Perhaps the comet was shrouded in unusually fine grains, scattering sunlight in a concentrated way. Perhaps the ice on its surface reflected with a crystalline intensity. Perhaps we were simply witnessing a quirk of geometry, the way the sun struck its surface, the way the Earth received that light. Science thrives on such perhapses, and they grounded the conversation. But the speculative edge grew sharper when energy calculations were introduced. For an object to sustain visible self-illumination, to glow brightly enough to rival reflection, it would need power on the order of 10 gigawatts. That is the energy of dozens of nuclear plants, radiating steadily into the void. No comet could sustain such output without tearing itself apart. 10 gigawatts is not the fire of frozen water. It is the fire of technology. The paradox pulled minds in opposite directions. To some, the glow was a reminder that our instruments are imperfect, that nature always finds ways to surprise. To others, it was a signal that we were no longer in familiar territory. Harvard astrophysicist Avi Loeb, already known for suggesting that ʻOumuamua might have been artificial, lent his voice again. A self-luminous interstellar visitor, he argued, might not be natural at all. It could be a probe or something stranger, designed to mimic a comet while carrying its own power source. This did not mean alien spacecraft in the cinematic sense. No windows, no engines, no crew staring back. It meant technology disguised as debris, a machine built to travel, perhaps for centuries, across interstellar distances. What better camouflage than the very bodies stars fling outward during their violent births? If a civilization wanted to send emissaries, why not hide them among the comets? Let them drift unseen until they arrived in another system. But against this speculation stood the counterweight of experience. David Jewett of UCLA, one of the foremost comet experts, stressed caution. He calculated dust ejection rates, 6 to 60 kilograms per second, ejected at velocities between 20 and 2,000 meters per second. Those numbers matched known cometary behavior, nothing more. Weak gas emission at 4 astronomical units was not suspicious. It was expected. Many comets remain silent until they pass closer to the sun. To leap from brightness to alien intent was, in his words, to run ahead of evidence. Yet even Jewett's sober assessments could not erase the unease. The profile remained unusual. The paradox lingered. In astronomy, light is truth, but sometimes truth fractures into interpretations, each pulling in a different direction. Consider how our ancestors once watched the sky. They saw comets as omens, bingers of change. The light in the sky was never just light. It was meaning, layered with fear and awe. In a way, nothing has changed. We still search for meaning and brightness in the way the cosmos chooses to shine upon us. The paradox of 3I Atlas was not simply data. It was a question whispered across observatories. What kind of body shines like this? What story does its glow conceal? If it is natural, then we are witnessing a fragment more reflective than most, or more enshrouded in dust, or oriented in some peculiar way that magnifies its light. That in itself is precious. A new kind of comet, a data point that stretches our models. If it is not natural, if the glow is real, self-generated, then we are standing on the edge of something we have only imagined in stories. Proof of engineering on a cosmic scale. And here is the heart of the paradox. Both outcomes are extraordinary. If natural, 3I Atlas expands the library of interstellar wanderers, showing us that the galaxy produces objects stranger than we expect. If artificial, it is the most important discovery in human history. In either case, the glow demands attention. As days turned to weeks, telescopes kept watch. Each image added detail, but not clarity. Each spectrum revealed minerals, ice, dust, and yet the brightness refused to align. And so the paradox deepened, drawing us further into the mystery of a visitor that shines too much, too strangely, too defiantly for comfort. The night sky is filled with countless lights, but very few ever change the way we see ourselves. 3I Atlas was becoming one of them. Before 3I Atlas, the cosmos had already offered us two whispers of the beyond. Each came uninvited, unpredicted. Each forced a re-evaluation of what interstellar visitors might look like. ʻOumuamua in 2017, 2I Borisov in 2019. Together, they set the stage, and yet, compared to 3I Atlas, both feel like preludes to a more complex story. To understand why this third visitor unsettled astronomers so deeply, we must revisit the echoes of those earlier encounters. ʻOumuamua, its name from Hawaiian, meaning a scout, a messenger from afar arriving first. When Pan-STARRS in Hawaii caught its faint trail in October 2017, it was already leaving. This was the cruel twist. Our first confirmed interstellar object was discovered too late for prolonged study. By the time astronomers realized what it was racing away from the sun at nearly 300,000 kilometers per hour. What little we learned was enough to ignite a firestorm of debate. Its shape, for instance, was inferred to be elongated, perhaps cigar-like, perhaps pancake-flat, spinning end over end like a cosmic shard. Its brightness varied erratically as it tumbled, more than any comet or asteroid seen before. Stranger still, it exhibited a slight acceleration, a subtle push away from the sun, as though propelled by an invisible force. Normally, such behavior is explained by outgassing, jets of sublimating ice pushing a comet along. But no cometary tail was visible, no gas was detected. Something was pushing it, and no one could say exactly what. Some argued it was a fragment of an icy planetesimal, baked into strangeness by time. Others whispered bolder thoughts. A light sail, perhaps, a thin sheet propelled by sunlight, an artifact of technology. Avi Loeb, then chair of Harvard's astronomy department, became the most visible proponent of this daring idea. His reasoning was simple. If an object behaves in ways that defy natural models, we must at least consider the possibility of artifice. Many dismissed the claim as reckless, but ʻOumuamua left us with no resolution, only questions fading into distance. 2 years later, in August 2019, the Crimean amateur astronomer Gennady Borisov spotted another interstellar traveler. 2I Borisov was unmistakably cometary, trailing a broad tail of dust and gas, venting as sunlight boiled its ices. It looked for all the world like comets we had always known, except it came from elsewhere. Its spectrum revealed familiar ingredients: water, carbon monoxide, cyanide, silicates. Here was a fragment of another system that behaved exactly as textbooks would predict. For many astronomers, it was a relief. It suggested that interstellar visitors were not necessarily exotic. not necessarily anomalous. They could be natural shards, frozen archives of alien stars, arriving by chance. And then, silence. No further interstellar objects crossed our sight for 6 long years. Some wondered if we had been lucky, if such detections were once-in-a-lifetime events. Others trusted that new, more sensitive surveys would reveal more in time. The Vera Rubin Observatory, still unfinished then, was expected to change the game. But before its eyes could open, Atlas in Chile caught something else. 3I Atlas. Why did this third visitor ignite such unease compared to the first two? Because it seemed to combine the mysteries of both while adding new ones. ʻOumuamua had been too strange, Borisov too ordinary. 3I Atlas stood in between, comet-like in composition, yet bizarre in brightness, orbit, and statistical improbability. It was as if the cosmos had taken the ingredients of the first two messengers and woven them into something neither fully natural nor comfortably extraordinary. Astronomers could not help but compare. Where ʻOumuamua had shown anomalous acceleration, 3I Atlas showed anomalous light. Where Borisov displayed the expected volatile plumes, 3I Atlas, so far, remained strangely quiet, as if holding its breath. ʻOumuamua's path had been inclined, angled oddly relative to the ecliptic plane. Borisov's was steep as well, diving through our system at a sharp angle. But 3I Atlas moved nearly along the plane of planets, retrograde, yes, but astonishingly aligned. This was not the random scattered angle expected of interstellar debris. This was something different. To some, the comparison painted 3I Atlas as a culmination. Humanity's first interstellar objects arrived like chapters of a story, each revealing more. ʻOumuamua teased us with the unimaginable. Borisov grounded us in the familiar. 3I Atlas now forced us to reconcile both, a paradox in motion, brighter than expected, stranger than convenient, yet cloaked in materials that whispered comet. Speculation thrived in this tension. Was 3I Atlas a natural object, but one so unusual it stretched probability to the breaking point? Or was it the deliberate camouflage of something else, an emissary disguised as debris, passing itself off as a cousin of Borisov, while echoing the anomalies of ʻOumuamua? In the quiet halls of observatories, in conferences and late-night emails, astronomers wrestled with these echoes. The public, too, drew its own comparisons. ʻOumuamua had captured imaginations worldwide, spawning books, documentaries, and debates about alien contact. Borisov, while scientifically rich, stirred less cultural frenzy because it behaved as expected. Now, with 3I Atlas, the old questions resurfaced with fresh urgency. Could we really be watching the passage of a probe, moving deliberately through our system? Or were we simply learning that interstellar objects come in more flats, vors than we ever dreamed? And beneath all of it lingered a deeper thought. What if these three were not outliers, but the first notes of a symphony? What if the galaxy is filled with such wanderers, countless fragments drifting from system to system, each carrying clues of alien chemistry, alien histories, perhaps even alien intent? If 3 arrived within less than a decade, perhaps they are not rare at all. Perhaps we had simply been blind until our telescopes sharpened their gaze. In this way, 3I Atlas became a mirror reflecting back the echoes of its predecessors. ʻOumuamua showed us that interstellar objects can be baffling. Borisov showed us that they can be familiar. And 3I Atlas showed us that they can be both at once, demanding we hold contradiction without resolution. It was no longer enough to classify, to check boxes. We were being asked to expand our imagination. Science advances not only through data, but through discomfort. The comparison of these three wanderers forced astronomers into that discomfort between natural and artificial, expected and impossible, certainty and wonder. Each messenger had come and gone, leaving us with only trails of light, calculations, and memories. None lingered long enough to yield final answers. All we had were echoes, and now those echoes converged on 3I Atlas, amplifying its mystery until it loomed larger than either of the two before. Perhaps that is why fear crept in. Not fear of invasion, not fear of doom, but fear of uncertainty. Fear that the universe is not only stranger than we suppose, but stranger than we can suppose. If 3 such objects could shake us so deeply, what of the next 10, the next 100? For now, the story rested on comparisons, on the faint trail of predecessors that had already slipped beyond reach. ʻOumuamua gone into the dark, Borisov dissolved by the sun, and 3I Atlas plunging inward, its riddle still unfolding. In those echoes, we heard the voice of the unknown, and that voice was growing louder. Among the many puzzles 3I Atlas offered, its path was the most unnerving. Motion through the solar system can be charted like brushstrokes across a canvas. Most comets sweep in on long ellipses, descendants of the Oort cloud, looping around the sun before retreating again into darkness. Asteroids remain confined to belts, steady and predictable, held in quiet resonance with planets. Interstellar visitors, too, are expected to cut across the planetary plane at random angles, for their origin is arbitrary, flung outward by chaotic gravity, cast into galactic drift. But 3I Atlas did not obey those expectations. Its orbit was retrograde, flowing backward against the direction of the planet's march. And yet, rather than slicing steeply through the solar plane, it moved almost along it, within only 5 degrees of the ecliptic, that fragile disk where planets, moons, and debris trace their paths around the sun. Retrograde, aligned, precise. The numbers told the story. The odds of such an arrangement, by chance, hovered around 0.2%, and when its future course was projected, skimming near Mars, brushing by the Sun, gliding close to Jupiter, the probabilities collapsed further, to less than 0.005%. For astronomers used to the chaos of celestial dynamics, such precision felt like choreography. Comets are dancers with ragged steps, chaotic partners of gravity. 3I Atlas seemed to follow a script. Imagine watching a leaf swept into a river. Most leaves tumble erratically, their paths dictated by chance currents. But now imagine one leaf gliding against the flow, hovering near stones, following a channel as though guided. Would you call it coincidence? Or would you suspect a hidden hand steering beneath the water? This was the dilemma 3I Atlas presented. If natural, its trajectory was astonishingly unlikely. The right angle, the right inclination, the right sequence of encounters all layered together. If not natural, then perhaps intentional, the path of a traveler seeking specific vantage points. Some pointed to Mars, where orbiters with high-resolution cameras would soon gaze skyward. Some pointed to the Sun, where its perihelion would occur at a moment Earth could not see, hidden by glare. Some pointed to Jupiter, with its immense gravity, capable of bending trajectories like a sling. Each approach seemed both coincidental and purposeful, as though the object were threading needles on a cosmic scale. The phrase that haunted discussions was reverse solar Oberth maneuver. In spaceflight, an Oberth maneuver is a trick. Dive close to a gravity well, fire engines at just the right moment, and the burn multiplies in efficiency, slingshotting a craft outward with far greater speed. Engineers dream of using the Sun itself for such maneuvers, though the danger is immense. But 3I Atlas seemed to be doing the reverse, diving near the Sun at a moment when Earth could not observe, adjusting its path invisibly. Was it a coincidence of celestial mechanics, or a deliberate cloak, a way to vanish behind the sun's blinding glare? Astronomers debated in quiet tones. Most leaned toward caution. Retrograde orbits, while rare, are not impossible. Interstellar space is vast, and when countless fragments are hurled across it, some will arrive with unusual geometries. The probabilities may be small, but given enough time, even small probabilities play out. To assume intent, they argued, was to mistake chance for design. But chance has limits, and 3i Atlas pressed against them. Consider again the numbers. A 0.2% chance for its angle, a 5,000th chance for its sequence of planetary passes. If you rolled dice at a table and drew such results again and again, would you not begin to wonder if the dice were loaded? This unease was not only mathematical, it was emotional, existential. We are used to thinking of our solar system as a fortress, a place where motions are predictable, where the planets spin like clockwork. An object that moves against that rhythm feels like an intrusion, like a note out of place in a symphony. Retrograde is the music of rebellion. To follow the ecliptic so closely while rebelling against its flow was like hearing a song sung backward, yet perfectly in tune. Even for those who dismissed technological speculation, the trajectory was an extraordinary teaching moment. It reminded astronomers how little we have seen of the galaxy's debris. With only 3 confirmed interstellar visitors, our statistics are shadows. Perhaps many such objects travel in strange alignments. Perhaps 3i Atlas is not rare, but typical, and our models are simply blind. If so, the future discoveries of the Vera Rubin Observatory may soon show us that the improbable is common. And yet, doubt persisted. Why now? Why this path, this timing, this precise veil of solar glare at perihelion? The questions echoed louder because answers could not yet be found. Instruments strained to follow its motion. Predictions tightened, charts sharpened, simulations spun. Still, the path remained uncanny, like handwriting whose author we cannot see. For those willing to dream, the trajectory raised possibilities that bordered on myth. A probe disguised as a comet, steering with subtlety, navigating not with rockets, but with careful nudges timed over centuries. A messenger designed to brush close to worlds, to pass by observatories, to test whether intelligence here would notice. If we did not, it would move on, its secret intact. If we did, then the experiment succeeded. And what came next? Silence or contact. It is in our nature to weave meaning into motion. The planets themselves were once gods in Huxians. Man's stories, their wandering paths across the sky, read as omens. We now understand gravity and mechanics, yet the temptation remains. When the improbable crosses our sight, we cannot help but wonder if it means more than chance. 3i Atlas was no different. Its retrograde glide through the solar plane was, in itself, a story too sharp to ignore. As the object drew closer, those probabilities shifted from abstraction to urgency. The Mars flyby on October 3rd promised a chance for imaging, a test of whether the choreography was as precise as predictions suggested. The perihelion on October 29th loomed larger, for it would pass just 1.35 astronomical units from the Sun, hidden from Earth's vantage. Then came the Jupiter encounter, a brush with the gas giant's vast influence, another improbable note in the composition. Each event carried weight. Each would either reinforce coincidence or deepen suspicion, and always the clock ticked. Interstellar visitors do not linger. They plunge in and out, their mysteries fleeting, their lessons brief. We had weeks, perhaps months, to watch before 3i Atlas retreated forever. Its path against the current demanded attention, demanded we confront the possibility that we were watching something more than a shard of ice. In the end, What does it mean for an object to defy the expected? It means our models must expand. It means our humility must deepen. It means the sky is still capable of surprise, even in an age when we imagine we have mapped and measured all that matters. The path of 3I Atlas was not just a trajectory. It was a statement written across the solar system that chance and mystery still walk hand in hand, that the improbable still finds a way, that we, for all our instruments and equations, remain students of a universe far vaster than our certainty, retrograde, aligned, improbable, a path against the current, whether guided by chaos or by something else. 3I Atlas reminded us that the cosmos is not a closed system of answers. It is an open question rushing past us in silence. Every orbit tells a story, and the story of 3I Atlas is written not only in its improbable alignment, but in its near embraces with worlds. When astronomers traced its path forward through time, they saw something extraordinary, a sequence of encounters so precise, so delicately arranged, that the mathematics itself seemed to whisper of choreography. The first act unfolds near Mars. On October 3rd, 2025, the object is set to pass within 29 million kilometers of the red planet. In cosmic terms, this is close enough to feel intimate, like a stranger brushing your shoulder in a crowded street. Mars, small and rusted, waits in its quiet orbit. Above it circle machines, the Mars Reconnaissance Orbiter, with its high-rise camera capable of resolving features smaller than a desk, and other watchers that peer down at plains and dunes. For a fleeting moment, those instruments might glance upward instead, capturing an interstellar visitor against the backdrop of stars. To see such an object from another planet's perspective would be unprecedented. It is as though Mars itself were lending us its eyes, reminding us that our search for understanding does not belong to Earth alone. The flyby is not a collision, not even close, but proximity matters in astronomy. The geometry of this pass is so rare that its probability hovers near impossibility. And yet, here it is, written into the sky. Then comes the sun. On October 29th, 2025, 3I Atlas will reach perihelion, its closest approach to our star. It will dive to just 1.35 astronomical units near the orbit of Mars, yet hidden entirely from Earth's gaze. From our vantage, the sun will blot it out, its glare too fierce, its light too overwhelming. This is the moment that unnerves many, for coincidence feels too delicate here. At the very time when we most wish to observe, the Earth lies on the opposite side of its orbit. The object will cloak itself behind solar fire, veiled from every terrestrial eye. Astronomers describe this as unfortunate geometry. Others see something else, a maneuver of stealth. The phrase returns again, reverse solar obirth. By diving behind the sun at such an angle, could 3I Atlas be adjusting its path unseen, testing our awareness, hiding deliberately in brilliance? Skeptics wave away such notions as human projection. After all, celestial mechanics are mercilessly indifferent. But when improbabilities layer themselves so thickly, the line between chance and design blurs. Consider the silence of that hidden moment. We will know the object is there, but we will not see it. We will chart its entrance into solar glare. We will calculate where it must emerge. But during those hours, it will be invisible, like a character stepping off stage before returning transformed. That darkness, that absence, will feed speculation as surely as light. And then, as though completing a triangle of encounters, 3I Atlas will pass near Jupiter, not grazing its atmosphere, not threatening collision, but slipping within 33 million kilometers, a distance that still allows the giant to extend its influence. Jupiter is the monarch of orbits, its gravity capable of bending trajectories like reeds in wind. Many comets we know are shepherded by it, deflected or consumed. For 3I Atlas to sweep so close is another improbable note in its score. What does such an encounter mean? To some, nothing more than chance alignment, the dice of the cosmos rolled once more. To others, it is as though the visitor seeks counsel with the system's ruler, acknowledging the massive planet that dominates all paths. If you were to design a journey through the solar system, Jupiter would be your pivot, a place to change course, to slingshot, to conserve energy. Engineers have done it countless times with probes from Earth. Could something or someone else do the same? Together, these three encounters form a pattern unlike any we have seen. Mars, the planet most watched by human eyes. The Sun, veiling secrets in its glare. Jupiter, the giant whose gravity writes destinies. It is like a pilgrimage, a deliberate procession past milestones of our own curiosity. Mars, where we search for life. The Sun, source of our light. Jupiter, our protector and warden. And through them moves a visitor whose origin is not our own. To feel the weight of this pattern, one must imagine scale. Space is vast, distances immeasurable in ordinary terms. The chance that an interstellar rock flung randomly from another star would thread such a needle defies ordinary probability. The odds, 1 in hundreds, 1 in tens of thousands, are figures too small to comfort. Of course, improbability is not impossibility. Given billions of years, the unlikely happens every day. Yet when the unlikely happens in our brief watch, we cannot help but feel singled out. Astronomers balance on this knife edge daily. They remind themselves improbable events occur naturally. Randomness produces patterns. To assume intent without proof is dangerous, a betrayal of rigor, and yet even they confess the unease. To watch this object trace such a path is to feel that we are part of a story larger than chance. There is another layer to these encounters, their symbolism. Mars is humanity's frontier, the world we dream of reaching, the stage of our future. The Sun is the eternal eye, the heart of our system, the source of all life here. Jupiter is the guardian, its gravity deflecting comets that might otherwise strike Earth. Together they form a trinity of meaning, and 3I Atlas passes each one as though acknowledging the narrative we ourselves have written. Coincidence? Almost certainly. Yet meaning seeps in regardless. When telescopes train on these encounters, they will not be searching for poetry. They will be searching for data, light curves, spectral signatures, gas plumes, dust tails. They will measure accelerations, trajectories, deviations. But for those watching from afar, the poetry cannot be ignored. A wanderer from another star brushes past our nearest neighbor, disappears behind our sun, bows near our giant. In these motions we glimpse the outline of mystery, framed not by imagination, but by mathematics itself. And still the question lingers. What will we see? Will Mars' reconnaissance orbiter capture a shape that defies cometary models? Will perihelion reveal jets of gas that explain the brightness paradox? Will Jupiter's gravity bend the path in a way that confirms natural chance? Or will anomalies remain, sharpening suspicion, deepening the sense that something is not what it seems? For now, all we can do is wait, calculations in hand, instruments ready. We know the dates, we know the geometry. The sky itself has scheduled the appointments. What we do not know is what we will learn, or how those lessons will echo through our understanding of the universe. Mars, the Sun, Jupiter, 3 encounters, improbable and precise. A dance through the heart of our system, written into the path of an interstellar stranger. Whether chance or design, coincidence or intent, the meaning is the same. We are not alone in our watchfulness. The cosmos sends visitors, and they pass near the very worlds we hold dearest. Perhaps this is only chance. Perhaps it is only stone and ice, wandering blindly. Or perhaps, just perhaps, it is choreography, and we are the audience, watching a performance written in the motions of the stars. To understand an interstellar visitor, astronomers turn to its light, not its brightness alone, but its spectrum, the hidden fingerprints etched across wavelengths. Every element, every mineral, every volatile gas absorbs and emits in unique patterns, leaving traces as distinctive as a signature. By splitting light into its colors, we can read the story of matter from afar. And so, when 3I Atlas appeared, telescopes across the world and in orbit strained to capture those spectral whispers. What they found deepened the mystery rather than resolved it. Water ice was there, not a surprise, for most comets are born of frozen reservoirs, fragments of stellar nurseries where planets coalesce. But this ice bore qualities that unsettled. Some readings suggested it was chemically pristine, untouched by the kinds of radiation and processing that shape the ices of our own system. In other words, it seemed younger, purer, as though it came from a cradle, far removed from the harshness of space. Its crystalline lattice gleamed in the data like something preserved in darkness for eons, released only now as sunlight brushed it awake. Alongside the ice were darker signatures, carbonaceous minerals, compounds rich in the element that is the backbone of organic chemistry. Silicates appeared too, rocky fragments not unlike those in our own comets and asteroids. In many ways, this was familiar. Carbon, silicate, water, the stuff of dust and planets. But context transforms the ordinary into the profound. For these were not fragments of our sun's nursery. They were relics of another star's beginning, matter forged light years away, billions of years ago, now crossing our sky. To hold even the idea of such matter is to feel the scale of cosmic kinship. The ice of 3I Atlas is alien in origin, yet water is the same molecule everywhere, 2 hydrogens and 1 oxygen bound in fragile embrace. The carbon is carbon. The silicates are silicates. The building blocks are universal, the same substances that shaped our Earth, our oceans, our breath. When we study 3I Atlas, we are not just analyzing a rock. We are touching another system's history, another star's chemistry, perhaps another world's memory. And yet, there was something too clean about it, too pristine. How could ice remain so unweathered across interstellar gulfs? Cosmic rays bathe every wanderer in radiation. Dust collisions erode surfaces. Time is merciless in the void. For such purity to endure, the object must have been shielded or born in conditions unlike our own, or, and here speculation enters, perhaps maintained. This last thought is where imagination collides with caution. Some dared to wonder whether the pristine quality was evidence not of preservation by chance, but of purpose. Could it be that the ice was freshly exposed, stripped of contaminants, like a cloak shed before entering our system? Could its composition be a mask, a disguise chosen to mimic a comet's chemistry while concealing something else within? Most astronomers reject such conjecture. They argue instead that the surface we measure may not be representative of the whole. A thin crust, fractured recently, could reveal ice unmarked by long exposure. Or perhaps the interstellar journey was shorter than we assume, ejected recently from a neighboring system, traveling not for eons, but only for millennia. In that case, the ice might well appear young, unscarred. And yet, even this natural explanation stirs wonder. If 3I Atlas is young, then we are witnessing debris from a star still near its birth, perhaps a system in chaos, flinging fragments outward in violent instability. It is as though the galaxy itself were offering us a sample of its present, not only its past. But beyond the ice and carbon, one absence caught attention: volatiles. Typical comets, when warmed, release gases: carbon monoxide, carbon dioxide, methanol, ammonia. 2I Borisov displayed these abundantly. ʻOumuamua did not, and its silence became part of its riddle. 3I Atlas, too, remained quiet longer than expected, showing no robust jets as it approached the inner system. Some scientists explain this as distance. At 4 astronomical units, sunlight is still weak, unable to rouse deeper ices. As it draws nearer, they predicted, activity will bloom. Others whispered that the silence was deliberate. David Jewett's team calculated that if gas is emerging, it must be weak, no more than 60 kilograms of dust per second, ejected at speeds between 20 and 2,000 meters per second. These figures fit comfortably within natural models. Nothing demanded the extraordinary, and yet, the brightness profile still resisted alignment. The silence of gas and the glow of light refused to marry in simple equations. To look at 3I Atlas is to confront a paradox of identity. Its spectrum says comet, ice, dust, minerals. Its behavior says anomaly, brightness too sharp, path too precise, silence too long. We find ourselves caught between categories, unwilling to discard the familiar, unable to dismiss the strange. The history of science is filled with such moments. When spectra first revealed the composition of stars, it was shocking to discover that the sun was mostly hydrogen, not Earth-like matter. When comets were first split by spectroscopy, we learned they were not omens, but archives of the solar system's birth. Each time, data dissolved assumptions. Perhaps 3I Atlas is the next such dissolution. What is it made of? Ice, yes. Carbon, yes. Silicates, yes. But also perhaps questions. Questions condensed into matter. Questions cloaked in dust. Questions shining back across light years. The very purity of its ice becomes a metaphor. Beneath the grime of speculation lies something clear, crystalline, waiting for us to understand. And there is a poetry in this, that a fragment of another star's nursery should wander here, carrying the same molecules that birthed us, that in studying its chemistry, we study ourselves, mirrored across interstellar distance, that we may never know for certain whether the pristine ice is natural preservation or deliberate disguise, but in either case, it forces us to widen our imagination. We are used to thinking of matter as inert, as indifferent, but matter carries stories. Every atom in 3I Atlas has traveled, bonded, broken, and reformed across spans of time we cannot fathom. Every grain of dust it sheds is a traveler older than human history, older than Earth's oceans, older perhaps than the very continents beneath our feet. To study it is to touch the deep past of another sun, another beginning. The question of what it's made of is, ultimately, a question of identity, and identity in the cosmos is rarely simple. A comet can be both familiar and strange, both archive and riddle. 3I Atlas, in its spectral silence and crystalline purity, embodies that duality. It is ice, and it is mystery. It is carbon, and it is question. It is silicate, and it is story. Perhaps as it moves closer to the sun, it will reveal more. Perhaps jets will flare, gases will roar, spectra will bloom with complexity. Or perhaps it will remain quiet, its pristine face intact, denying us the comfort of confirmation. Either way, we will watch, instruments poised, imaginations restless, for in every glimmer of its light, we see not only what it is, but what it might be. And what it might be, natural wonder or engineered emissary, is a question that binds our gaze to the stars with awe and trembling. Silence in the cosmos can be as loud as any signal. When astronomers turned their instruments toward 3I Atlas, many expected the familiar whisper of outgassing, faint jets of vapor and dust, the hiss of ices turning to vapor under the warmth of the sun. Comets speak in this language. As they approach, they awaken, shedding veils of gas and trailing tails across the night. But 3I Atlas, even as it drew closer, remained mute. This quiet unsettled. It is one thing for an object to shine too brightly or to move along improbable paths. It is another to remain still in behaviors where activity is expected. The cloak of silence draped over 3I Atlas became part of its enigma, raising questions about what it truly was. To understand this, we must return to cometary norms. A typical comet begins to stir once it crosses about 4 astronomical units from the Sun, a distance where heat is still faint, but sufficient to rouse the most volatile ices like carbon monoxide and carbon dioxide. The Sun's radiation penetrates its surface, warming pockets of frozen gas which burst forth and drag dust along in great plumes. Telescopes detect these as emissions in ultraviolet, infrared, or visible wavelengths. It is as though the comet has begun to breathe. But for 3I Atlas, the breath never came. Observatories tuned to sniff for gas found only whispers, if anything at all. Hubble, Gemini South, the NASA Infrared Telescope Facility, all strained for signs. And while dust may have been lofted, the clear signature of strong volatiles was absent. Some called this a delay, insisting the activity would come closer in, that perhaps its crust was thicker, its ices buried deeper. Others felt the silence was telling us something fundamental about its nature. David Jewett's models offered a calm perspective. His team estimated dust production at perhaps 6 to 60 kilograms per second, not zero, but meager. The velocities of ejected material ranged from 20 to 2,000 meters per second within normal cometary ranges. In his view, nothing about this was extraordinary. Weak activity is common, especially at such distances. To leap to conclusions was to let wonder distort measurement. Extraordinary claims require extraordinary evidence, he reminded his colleagues, invoking the old caution of Carl Sagan. Yet even Jewett could not explain the persistence of the brightness paradox. If the glow was only dust reflecting sunlight, then the low outgassing rates seemed insufficient to sustain such brilliance. The silence and the glow remained in conflict, like two instruments out of tune in the same orchestra. The human mind, confronted with silence, invents meaning. In ancient times, a comet that refused to appear on schedule was a bad omen. Today, when an interstellar visitor remains quiet, the silence becomes a canvas for speculation. Could it be dormant, a comet whose surface has hardened into an insulating shell? Could it be hollow with little volatile material at all? Or could the silence be a mask, deliberate suppression of outgassing to avoid notice? That last possibility, however unlikely, carried with it a whisper of unease. A machine disguised as a comet would have every reason to minimize emissions. Jets of gas would betray its nature, expose its heat, reveal activity inconsistent with stone and ice. Silence would be safer, stealthier. Silence would be intentional. Such speculation cannot be proved, and most scientists resist it. Yet the parallels are striking. Human spacecraft, when traveling, are designed to remain quiet, conserving energy, limiting emissions, masking heat when possible. If we project forward into a civilization more advanced than ours, might they not do the same? Cloak their travelers in silence, drifting as comets until Curiosity compels someone to look closer. But even without speculation, the silence is a scientific gift. It forces us to confront our assumptions about interstellar comets. Perhaps many of them are quiet until very near the sun. Perhaps our catalog of cometary behaviors is too narrow, shaped only by local examples. Perhaps 3I Atlas is not unusual in silence, but typical, and only seems strange because we expect echoes where there are none. If so, then silence itself becomes a lesson, that the galaxy is filled with bodies that speak less loudly than ours. Still, the paradox persisted. If it is natural, then the silence is frustrating, but explicable. If it is not, then the silence is terrifying, like a paused breath in the dark. Silence invites imagination. Silence feeds fear. Imagine standing in a forest at night. You hear nothing. No leaves, no wind, no insects. The absence itself feels alive, as though something watches. 3I Atlas evokes the same sensation. Its quiet is not emptiness. It is presence without explanation. The cloak of silence is also temporal. It is not permanent. Astronomers know that as it nears the sun, heat must eventually awaken it. If no gas emerges even then, the silence will become louder, harder to ignore. If emissions finally burst forth, the paradox may resolve, but only partially, for the brightness problem remains. Either way, the silence has already played its role. It has unsettled us, reminded us that not all comets behave according to the scripts we write for them. It is worth recalling that ʻOumuamua, too, was silent in this way. It showed no jets, no tail, no emissions, even as it accelerated inexplicably. It forced the same debate, the same division between natural anomaly and artificial intent. Borisov, by contrast, roared like a comet should, its gas abundant, its tail wide. In silence, 3I Atlas echoes ʻOumuamua more than Borisov, and that echo amplifies suspicion. But suspicion is not certainty. Silence is not proof. The scientific mind thrives in the space between. We measure what we can, we imagine what we must, and we accept that the unknown remains larger than either. What we can say is this: the cloak of silence is as much part of the identity of 3I Atlas as its path or its brightness. It is a silence woven of ice, dust, and probabilities. It is silence that sharpens the imagination and humbles the intellect. It reminds us that the universe does not owe us answers. It gives us riddles instead, and waits to see what we make of them. In the coming months, instruments will test whether that silence endures. The James Webb Space Telescope will look for faint infrared signatures of hidden outgassing. The Mars Reconnaissance Orbiter may catch dust plumes invisible from Earth. If silence holds, the speculation will grow. If the silence breaks, a new chapter begins. Either way, we are listening, straining our instruments against the void, hoping to hear something more than quiet. But for now, the silence remains, a cloak drawn tightly around a visitor whose nature we do not yet know. And in that silence, we hear our own questions echoing back. Light is the oldest language of the universe. It is the medium through which stars announce their births, through which galaxies whisper across billions of years, through which atoms reveal their innermost structures. Every glimmer in the night sky is the release of energy, a translation of power into radiance. And so, when 3I Atlas shone more brightly than expected, astronomers turned not only to geometry and reflection, but to the question of power itself. How much energy would it take to sustain such brilliance if the light were self-made, not borrowed from the sun? The answer was staggering: 10 gigawatts. To most of us, that number is abstract, a cluster of syllables without weight. But let us make it tangible. 10 gigawatts is roughly the combined output of 10 large nuclear power plants operating at full capacity. It is more than the electrical consumption of entire nations. It is the firepower to light millions of homes, to drive industries, to power fleets, to sustain it steadily across the void in a body no larger than a mountain. That is not mere anomaly. That is a paradox bordering on the impossible. If 3I Atlas truly glowed with its own energy, then it is not simply a comet. It would be something else entirely. An engine hidden beneath ice, a furnace disguised as stone. Natural processes on such a scale are rare, perhaps inconceivable. Comets do not burn like lamps. Their brilliance is borrowed, never owned. For an object to shine of itself, to carry power equivalent to the heartbeat of civilizations, suggests either a mechanism we have never observed or an intent we cannot yet comprehend. What could provide such power naturally? The mind searches for analogies. Perhaps radioactive decay, as in uranium or thorium-rich bodies releasing heat from within. But decay is slow, uneven, not luminous in visible wavelengths. Even the densest cores of radioactivity ore on Earth cannot sustain brightness equivalent to a city's lights, much less a global grid. Perhaps chemical reactions? Yet the chemistry of ice and dust is poor fuel for such flames. Perhaps impact heating, a body fractured and colliding, its energy released in sparks. But no such collision accompanied 3I Atlas. It arrived intact, silent, steady. The natural paths dwindle quickly, leaving only mystery. And so inevitably, imagination leaps to the artificial. 10 gigawatts is not only vast, but familiar. Familiar because it is the scale at which our own species dreams of power. We build reactors, dams, and grids to harness such energy. We know what it means to command that magnitude of force. To see it potentially mirrored in the sky is to see ourselves reflected back, but scaled to interstellar ambitions. Avi Loeb and others dared to voice this speculation. If the brightness were indeed self-illumination, then perhaps 3I Atlas was not a rock at all, but a vessel, a probe carrying a power source designed to mimic cometary behavior while hiding an engine. 10 gigawatts would not only light its shell, but drive systems, propulsion, communication, sensors, enough to keep it alive for centuries of wandering between stars. Of course, such thoughts skirt the line between science and fiction, between cautious hypothesis and unrestrained dreaming. Many recoil from them, not out of lack of curiosity, but out of loyalty to discipline. The simplest explanation must be sought first. Reflection, dust, geometry, these remain the anchors. To leap into alien engineering is to abandon the comfort of parsimony. Yet the calculation hangs there, undeniable. 10 gigawatts. To dismiss it requires explanation. To accept it requires revolution. There is another possibility. Perhaps the light is not steady power, but transient. Perhaps we witness a flare, a rare release of stored energy, something akin to cometary outbursts observed in our system. Jets of gas bursting suddenly, scattering sunlight more intensely than usual. If so, then the brightness may fade, the paradox resolve. But if it does not fade, if the glow holds steady, then the question remains. It is worth remembering how our species has often been surprised by scale. Once, it seemed impossible that stars were suns, burning with energies dwarfing comprehension. Once, it seemed absurd that galaxies could number in the billions, each with hundreds of billions of stars. Again and again, the universe has revealed magnitudes that humiliate our expectations. Perhaps 3I Atlas is another such humbling. a natural mechanism of light we have never imagined, as ordinary to the galaxy as gravity, simply overlooked until now. But the human heart cannot resist the other possibility. 10 gigawatts sustained is not only a calculation, it is a voice, a presence, a weight. If something built such a machine, then it was not a civilization like ours, still bound to its planet, still fumbling with rockets. It was a civilization capable of patience, capable of dispatching emissaries across light years, capable of sustaining power far from any sun. Such a civilization would see us as we see ants, small, fragile, brief. To encounter even a fragment of its work would be to stand before a cathedral raised by minds we can barely conceive. And yet, perhaps we are flattering ourselves. Perhaps there is no cathedral, no mind, no message. Perhaps the 10 gigawatts are an illusion of calculation, a misinterpretation of scattered light. Perhaps we are projecting our hunger for contact onto an indifferent stone. Science leans toward this, that natural explanations will suffice, that energy is not what it seems, that chance and dust can mimic power. The weight of caution insists we remain grounded, but even within that grounding, awe remains. To imagine that a comet could trick us into believing it carried power equivalent to nations is astonishing. To realize that our instruments, delicate as they are, can detect such subtleties across hundreds of millions of kilometers is humbling. Whether natural or not, the fact that we can even pose this question, could a body shine with 10 gigawatts of self-made light, is itself a milestone of wonder. And wonder is the truest power of all. It drives the telescopes, the papers, the debates. It fuels the questions whispered across late-night observatories. It is why we keep watching, keep measuring, keep dreaming. Because in the end, the question of power is not only about 3 Atlas, it is about us. What does it mean for us to measure power against the cosmos, to imagine civilizations hidden among comets, to consider our place in a galaxy where light may not always mean what we think? If 3I Atlas is natural, then it teaches us humility, expands our physics, stretches our models. If it is artificial, then it rewrites history, revealing that intelligence beyond Earth has already left fingerprints on our sky. Either way, the energy calculation is a mirror. In it, we see our fears, our hopes, our science, our myths. 10 gigawatts, a number, a possibility, a riddle. Perhaps the object is no more than ice and stone, and the brightness will fade as it passes. Perhaps it will remain luminous, defiant, carrying secrets we will never touch. Either way, its light continues to fall on our instruments and through them onto our imaginations. In the silence of space, power speaks, and in the glow of 3I Atlas, power whispers of something beyond reason. In every age of discovery, voices divide. Some lean toward bold interpretation, reaching beyond the edge of evidence into speculation. Others stand anchored in caution, defending the rigor of established models. Between them, tension forms, a dialogue as old as science itself, as old as curiosity and fear. 3I Atlas, with its strange light, improbable path, and cloak of silence, became the latest catalyst for this eternal division. On one side stood those willing to speak aloud what many only whispered. Harvard astrophysicist Avi Loeb, already infamous for his claim that ʻOumuamua might have been artificial, did not shy from the suggestion that 3I Atlas could be a probe, a machine disguised as comet. He pointed to the brightness paradox, to the retrograde orbit improbably close to the ecliptic, to the sequence of planetary flybys. Taken together, he argued, these were not the signatures of random debris, but of deliberate navigation. If one improbable anomaly can be dismissed as chance, what do we call 3 layered upon one another? Loeb's voice was both celebrated and criticized. To many, he represented courage, the willingness to ask questions others fear. To others, he embodied recklessness, the temptation to leap to extraordinary claims without extraordinary proof. But whether admired or scorned, his words carried weight, for they echoed the unease even skeptics felt in private. On the other side stood scientists like David Jewett of UCLA, guardians of restraint. Jewett is one of the most respected cometary experts alive, his work tracing decades of careful study. His calculations for 3I Atlas showed dust production rates within normal ranges, 6 to 60 kilograms per second, ejected at velocities from 20 to 2,000 meters per second. These numbers matched known cometary activity. Weak gas emissions at 4 astronomical units were not unusual. Many comets remain dormant until closer. To Jewett, 3 Atlas was strange, yes, but still within the wide variability of natural behavior. To leap to alien technology, he warned, was to abandon the discipline that gives science its credibility. This divide was not hostile. It was not 2 armies facing one another, but 2 instincts within the same community: curiosity versus caution, imagination versus discipline. The tension between them is what propels discovery forward. If all were cautious, no horizons would expand. If all were reckless, no truths would hold. It is in the balance, the push and pull, that understanding grows. Still, the split was palpable. Conferences buzzed with debate. Journal articles circled the paradoxes cautiously, hinting at anomalies, but framing them in sober language. Public interviews revealed the deeper rifts. Some astronomers spoke only of natural explanations, refusing even to utter the word artificial. Others allowed themselves to indulge the thought, if only for a moment, as if tasting forbidden fruit. What makes the artificial hypothesis so divisive is not only its content, but its consequence. To suggest alien technology is to leap from data into worldview. If 3I Atlas were a probe, then we are not merely observing debris. We are encountering intention. We are being watched, tested, perhaps even visited. Such a claim does not end in the pages of a journal. It spills into culture, religion, politics. It shifts humanity's self-perception. To declare such a thing requires proof beyond reproach, a standard almost unreachable. And yet, to refuse to even consider it is to risk blindness to the extraordinary. This is the knife edge on which scientists balanced. Loeb asked, should we not prepare for the possibility, even if remote? Jewett replied, should we not resist the temptation of myth, even if alluring? Between them stretched the landscape, ape of uncertainty, lit by a comet that might not be a comet at all. The division also revealed something deeper about humanity's psyche. For some, the idea of alien technology is exhilarating. It promises contact, expansion, the confirmation that we are not alone. For others, it is terrifying. It suggests vulnerability, irrelevance, the possibility that we are observed by powers far beyond us. Science is not immune to these emotions. Behind the equations and spectra, human hearts beat, shaped by hope and fear alike. 3I Atlas became a screen onto which we projected both. Even within individuals, doubt and belief wavered. A scientist might publish cautious models by day and lie awake at night wondering, what if? What if the glow really is artificial? What if the trajectory really is designed? What if silence really is concealment? The human mind can hold 2 contradictory truths at once: skepticism in the lab, wonder in the dark, and the public, watching from outside, amplified the debate. News headlines seized upon words like alien probe, not dust production rates. Social media lit with speculation, half jokes, half serious, that we were being visited. The narrative of technology always outpaces the narrative of caution. It is more compelling, more cinematic, more human. But beneath the frenzy, the scientists carried the weight of responsibility to speak truth, not fantasy, even when fantasy is tempting. The history of astronomy is filled with similar divides. The canals of Mars, once mapped with certainty, later revealed as illusions. Pulsars, once labeled LGM, little green men, before identified as neutron stars. Each time, bold speculation flirted with error, and cautious skepticism eventually triumphed. But each time, too, speculation opened doors. Without wonder, pulsars might have been ignored. Without imagination, canals might never have been mapped at all. Science needs both voices, doubt and belief, balanced intensely. And so it is with 3I Atlas. The doubters remind us that comets are wild, varied, unpredictable. The believers remind us that the universe may hold more than rocks and ice. Together they form a dialogue, one that resists final answers but enriches our vision of the cosmos. In the end, the truth may not satisfy either camp fully. Perhaps 3I's Atlas is natural but unusual, forcing new models of interstellar cometary behavior. Perhaps it is artificial, but we will never know, lacking proof before it vanishes back into the dark. Perhaps it is both, natural in origin, but shaped by forces we cannot yet measure. Whatever the case, its role is already fulfilled. It has forced us to ask. It has forced us to divide, to argue, to stretch the boundary between science and imagination. For what is science if not the art of asking? And what is belief if not the courage to consider answers we cannot yet prove? Between doubt and belief, humanity hovers, watching a silent, glowing traveler pass by, wondering whether we are alone, fearing whether we are not. The voices will not reconcile. They will not converge before the object is gone, but their very discord is the music of discovery. In the silence of space, 3I Atlas has spoken, not with words or signals, but by dividing our minds, testing our willingness to imagine and our discipline to resist. Perhaps that was the message all along. The human eye, unaided, sees only a faint smear of starlight when turned toward the heavens. For most of history, the sky was a canvas of mystery, its details locked beyond reach. But we have learned to extend our sight, to build glass and mirrors and orbiting machines that open the invisible to view. Every telescope is an augmentation of our gaze, every probe an extension of our curiosity. And so, when 3I Atlas appeared, when its improbable brightness and path unsettled astronomers, the first question was simple: which eyes will watch? The answer? All of them. The Hubble Space Telescope, still orbiting after more than 3 decades of service, was among the first to turn. Its mirrors, polished to near perfection, captured the faint glow of the traveler against black. Hubble measured the steepness of its brightness profile, revealing the paradox that still confounds. To some, it was like holding a lantern up to a shadow in the forest, illuminating only enough to see how much more remained hidden. But Hubble is a relic of another era, designed before we knew interstellar visitors would come. Its resolution is high, but its sensitivity is limited compared to the new Titan, the James Webb Space Telescope. JWST, parked 1 million miles from Earth at the stable L2 point, gazes in infrared, seeing heat and chemistry invisible to our eyes. For 3I Atlas, Webb is the most powerful eye we have, capable of detecting faint thermal signatures, probing whether the object is truly silent or only whispering at wavelengths our older instruments cannot hear. Astronomers schedule precious time on Webb carefully. Every observation is weighed against countless proposals. But 3i Atlas forced priority. To miss the chance would be to close our eyes when the cosmos had opened them. And so, JWST prepares to trace the glow of this visitor, to test whether dust is warmed naturally by sunlight or something stranger lies beneath. Meanwhile, another set of eyes waits on Mars. The Mars Reconnaissance Orbiter, circling high above the rust-red planet, carries HiRISE, the high-resolution imaging science experiment. HiRISE can see boulders as small as a dining table from orbit, photographing dunes, cliffs, and rover tracks with astonishing clarity. On October 3rd, when 3i Atlas sweeps within 29 million kilometers of Mars, MRO may point its camera upward instead of downward, seeking to capture an interstellar object from the perspective of another world. Imagine it, a photograph not from Earth, but from Mars, of a visitor from another star. No image like it has ever been taken. If HiRISE succeeds, it will be a moment of history, the first time a neighboring planet has joined us in witnessing the passage of an alien fragment. Even more powerful eyes are still being built. In the mountains of Chile, the Vera C. Rubin Observatory nears completion. Its 8.4-meter mirror will sweep the entire sky every few nights, compiling the most complete survey humanity has ever attempted. Where Atlas caught 3i, Rubin will catch dozens, perhaps hundreds, of interstellar wanderers each year. Rubin is not only an eye, but a census taker, promising to transform statistical improbabilities into patterns. If 3i Atlas seems strange now, Rubin will tell us whether it is unique or one of many. Was its path truly miraculous, or merely the first of a type we had never before noticed? But beyond instruments dedicated to astronomy, there are other eyes. Planetary defense telescopes track asteroids threatening Earth. Spacecraft orbiting Jupiter and Saturn monitor their skies. Even the Mars rovers, with cameras meant for geology, can glance upward. Each machine becomes part of the vigil. Each lens, each sensor, is a pupil widened to the dark, seeking answers in a silence that stretches light to years. We might imagine ourselves as a species huddled around a campfire, the fire being our sun, and 3 Atlas, a shadow moving just beyond its glow. To track that shadow, we lift every torch, every lantern, every crafted lens. Our instruments are our watchfulness. They are our declaration that we will not let the universe pass unexamined. There is poetry in the thought that machines we launched decades ago, machines built for other purposes, now turn to face this visitor. Hubble was designed to measure galaxies and nebulae, yet here it is chasing an interstellar comet. MRO was meant to map Mars's canyons, yet it may glimpse a star-born wanderer. JWST was envisioned as a time machine to study the infant universe, yet it bends its mirrors toward a single shard entering our system. The cosmos, indifferent, gives us riddles. We answer with whatever tools we have, no matter their intended use. And even these instruments are not enough. Radio telescopes, part of the SETI network, have quietly tuned their dishes toward 3i Atlas. Not because anyone expects signals, none have ever been found, but because one must listen when a stranger passes. The silence of radio waves is part of the silence that defines this object. To ignore it would be to close an ear when the universe might be whispering. Still, limitations gnaw at us. Telescopes can measure light, but not intent. They can see spectra, but not purpose. Instruments can reveal what something is made of, but not why it is here. Even with all our eyes open, the heart of the riddle may remain out of reach. And yet, this is the essence of science. To look anyway, to measure what we can, to press against the edges of knowability. The watching is itself a kind of answer. It tells us we are ready. It tells us we care. It tells us that when the cosmos delivers the improbable, we will not look away. Perhaps that readiness is what matters most. Not whether 3I Atlas proves to be a comet or a craft, but that we mobilized our vision, sharpened our instruments, and faced the unknown with open eyes. And what eyes they are! Mirrors in space, sensors on planets, dishes tuned to silence, cameras buried in deserts and mountains. They are our collective sight, humanity's gaze turned outward. They embody a truth older than technology, that curiosity is survival, that watching is the first act of understanding. When 3I Atlas finally slips beyond view, when it vanishes back into the dark, our instruments will rest again, waiting for the next. But the memory of this vigil will remain, the knowledge that we turned all our eyes skyward, that we did not blink, that we chose to see. That is what will endure. For whether 3I Atlas is stone or signal, comet or craft, it has already done its work. It has made us look. Every discovery lives in context. A single anomaly may be dismissed, a curiosity filed away as noise. But when patterns emerge, when echoes repeat, context transforms the strange into the significant. For most of human history, interstellar objects were the stuff of theory, mathematical ghosts predicted but never seen. Then, suddenly, within less than a decade, 3 appeared. ʻOumuamua in 2017, Borisov in 2019, and now 3I Atlas in 2025. What once seemed improbable now feels inevitable, and inevitability changes everything. If 3 have passed so quickly, how many more remain unseen? How many wanderers cut across our system every century, every year, every month? Their paths too faint or distant for our limited instruments. The question haunts astronomy like a shadow at the edge of vision. We are only beginning to widen our gaze, and already the universe has responded with visitors. What will happen when our sight expands further? This is the promise of the Vera C. Rubin Observatory, a new sentinel rising in the mountains of Chile. With its immense 8.4-meter mirror and its revolutionary wide-field camera, Rubin will survey the entire sky every few nights. Unlike older telescopes that stare at narrow patches of stars, Rubin will sweep vast swaths, building a time-lapse portrait of the heavens. Every flicker, every motion, every faint intruder will be recorded. It will be, in essence, the world's memory of the sky, refreshed endlessly. For interstellar objects, Rubin is a revolution. No longer will we depend on chance, a pan-stars in Hawaii catching a streak late, or an amateur in Crimea stumbling on a comet. Rubin will find them systematically, relentlessly, turning the rare into the routine. Astronomers predict dozens of interstellar detections each year once it begins operation. Instead of isolated case studies, we will have a statistical population. Instead of marveling at improbability, we will measure probability. Instead of 3 visitors, we may have 300. What will such a flood reveal? Perhaps that 3I Atlas is not unique at all, but typical, that many interstellar bodies shine oddly, travel along curious alignments, skim close to planets by chance. Perhaps the anomalies we see are simply what happens when you finally look often enough. Or perhaps the opposite, that even among many, 3I Atlas will remain unusual, its brightness sharper, its path stranger, its silence deeper. If so, the anomaly will harden into significance, a beacon among wanderers. Beyond numbers, Rubin promises something subtler, a map of galactic exchange. Every interstellar comet is a messenger from another star, carrying with it the chemistry of alien nurseries. By cataloging them, We will sample the ingredients of other systems without ever leaving our own. Some will be rich in carbon, some barren, some will carry crystalline ice, others amorphous dust. Together, they will tell us how stars are born across the galaxy, how planets form, how matter travels between suns. The Milky Way will no longer be a distant abstraction. It will be a place of exchange, its stars sharing debris like letters carried across cosmic distances. There is also a deeper possibility, one that borders on myth. If a civilization wished to send probes disguised as comets, as Loeb and others suggest, then Rubin will be our first real test. One anomaly may be dismissed, two may be coincidence, but in a sample of hundreds, patterns may emerge. Do some interstellar visitors behave statistically unlike the rest? Do some show improbable alignments, improbable energy signatures, improbable silence? If so, then the debate around 3I Atlas will not end with its passing. It will expand into a new field, the search for disguised technology in the flow of galactic debris. Even without that speculation, Rubin's promise is profound. For the first time, we will watch the galaxy not as a static dome, but as a living system, its fragments arriving daily, its exchanges constant. The boundary between our solar system and interstellar space will blur. We will feel less isolated, less like a single oasis, more like a node in a network of wandering messengers. Think of how human perspective has shifted with each expansion of vision. Galileo's telescope revealed moons orbiting Jupiter, shattering the belief that Earth was the cosmic center. Hubble's deep field revealed galaxies in the thousands, overturning the illusion that the Milky Way was the whole universe. Rubin may perform a similar transformation. By filling the sky with interstellar comets, it will remind us that we live not in a closed system, but in a galaxy alive with exchange. And within that exchange lies possibility. If matter travels between stars, then so too may seeds. Organic molecules, amino acids, the raw materials of life, flung outward in icy shells, carried across gulfs, delivered like spores. Panspermia, once a fringe idea, gains strength with every interstellar visitor we detect. 3. Atlas may not be alive, but it carries within it the chemistry of life. Multiply it by thousands, and the galaxy becomes not only a graveyard of frozen rocks, but a garden in transit. The expanding frontier, then, is not only technological, but existential. With Rubin, we will no longer be blind to the messengers. We will see them come and go, measure them, classify them. We will learn whether 3I Atlas was extraordinary or ordinary. And in that answer lies another question. If extraordinary, then why? If ordinary, then what does it say about the abundance of such bodies? Either outcome changes how we see ourselves. For astronomers, the anticipation is electric. Every visitor discovered before Rubin feels like a prologue, a prelude to the main act. ʻOumuamua was the opening whisper, Borisov the first confirmation, 3I Atlas the unsettling riddle. What comes next will be data not in threes, but in thousands. The frontier is not one object, but a flood of them, and humanity is poised to witness it. Yet even with that flood, even with Rubin's gift of sight, some mysteries may remain unsolved, for the visitors move fast, too fast to chase. Even if we detect dozens, we will still see them only briefly from afar. To truly understand, to peel away the silence and brightness and paradoxes, we will one day need to go to them. Missions are already being imagined, spacecraft on standby, ready to launch at a moment's notice, intercepting the next visitor before it vanishes. The frontier will expand not only in our eyes, but in our reach. And when that day comes, when a human probe meets an interstellar probe, whether natural or artificial, the line between astronomy and contact will blur. We will no longer wonder from a distance. We will touch, measure, perhaps even hold a fragment of another star in our hands. Until then, we wait and we watch. The expanding frontier is not only out there in the sky, it is within us. Our willingness to see, our capacity to imagine, our hunger to know. 3I Atlas is a reminder of that hunger, a spark before the blaze that Rubin will ignite. It tells us that the galaxy is alive with wanderers, and that soon we will see them not as anomalies, but as neighbors. The frontier expands, our eyes widen, and with each widening, the universe grows stranger, more beautiful, and more full of questions than we ever believed. The sky has always been a mirror of our questions. We search its darkness not only for light, but for meaning. And in the passage of 3 Atlas, the questions have multiplied. What is it? Why here? Why now? Was it a shard of some ancient star system? Or was it something more? A vessel, a probe, a test of our awareness? No answer came. Not through Hubble's eyes, nor Webb's infrared gaze, nor the instruments orbiting Mars. Not through spectral lines of water ice and silicate dust, nor through probabilities calculated on chalkboards and computer screens. The object moved, the object glowed, the object slipped past, indifferent. It did not speak, it did not turn, it did not reveal itself. And yet, in its silence, it spoke volumes. For what is science, if not the art of listening to silence? The silence of the vacuum between stars. The silence of light that has traveled billions of years to touch our retinas. The silence of a rock or a machine that sweeps into our system and out again, offering no explanation, only a riddle. Some scientists framed the riddle as cometary behavior, pristine ice, dust production, sublimation beginning only when the traveler neared warmth. Others insisted on improbability, the retrograde orbit aligned too neatly with the ecliptic, the statistical odds of its planetary encounters so small they seemed deliberate. Still others stood between, neither dismissing nor embracing the possibility of intent, content to admit, we do not yet know. But to not know is not failure, it is an invitation. 3I Atlas may never yield its truth, but in its passing it has given us something rarer, the sharpening of our questions, the widening of our gaze, the reminder that discovery is less about answers than about wonder. The final days of observation carried a strange weight. Astronomers watched its perihelion slip behind the sun, hidden from Earth's view for weeks. We could not see it. It was as if the object had stepped behind a curtain, choosing privacy in its closest moment to the fire. Some said coincidence, others whispered camouflage. Perhaps it wanted to pass unseen. Perhaps that was its maneuver all along. We could only wait, watching the sun's glare, until at last it re-emerged, faint, dimming, climbing outward again toward the black. By then, the debates were less urgent. The world had moved on, news cycles turning their restless wheels. But the astronomers kept vigil, watching the light curve decline, measuring until the faint streak faded beyond reach, until there was only darkness again, and the knowledge that something had passed, something we may never touch again. And so we are left not with conclusions, but with the question that remains. Was 3I Atlas natural or artificial? Was it comet or craft, wanderer or emissary? Will we ever know? Or will it join the long list of mysteries humanity carries, unsolved, into the future? Yet perhaps that is the deeper gift, that we are reminded of how much we do not know, that the universe is not an answered book, but an endless unfolding, that each visitor, no matter its nature, is a call to humility, a summons to imagination. The Vera Rubin Observatory will soon watch the sky with tireless eyes. Dozens more interstellar visitors will come. Some may prove ordinary, others extraordinary. Patterns will form, statistics will build, debates will sharpen. But even then, there will be questions without answers. For science is not the conquest of mystery, it is the companionship of it. And so, as 3I Atlas fades into the dark, we fade with it into reflection. We imagine it now, already far beyond Mars, gliding past Jupiter's orbit, soon beyond Saturn's cold rings, headed outward into the Gulf, where Voyager sails, where sunlight weakens into night. One day, centuries hence, it will leave the sun's domain entirely, back into interstellar silence, another orphan in the endless drift between stars. Perhaps it will wander for millions of years more, unseen, unnoticed. Perhaps one day, another civilization will see it, point their instruments toward it, and wonder in their own language what it is. And maybe that is the most humbling thought of all, that we are not the only ones who look at the dark sky and ask, that somewhere, sometime, others may stand under alien constellations, watching an interstellar shard and asking, is it natural or is it made? Is it mere rock or is it message? The question that remains is not a weight, but a thread that ties us to every astronomer who has ever lifted their eyes. To Galileo, watching moons orbit Jupiter. To Vera Rubin, proving galaxies rotate faster than gravity alone could explain. To the nameless observers who thousands of years ago carved the movements of stars into stone. We are all bound by questions that exceed our answers. And in the asking, we are alive. Now, as we drift back from the stars, let the rhythm of the cosmos slow. Imagine the faint hum of space becoming softer, the motions of planets gentler, the light of distant suns dimming into a restful haze. The rush of 3I Atlas slows in our minds, becoming not a roaring anomaly, but a quiet point of light, fading. Its mystery does not demand urgency now, it invites rest. Feel the vastness narrowing, returning from the galaxy to the solar system, from the solar system to the Earth, from Earth to your body, here and now. The breath in your chest is its own rhythm, steady, certain, a reminder that even as stars wander, even as questions stretch to infinity, there is peace in the smallness of being. The night sky remains above, but the need to answer can wait. The cosmos is patient. The universe does not rush, and neither must you. Rest now in the knowledge that we do not need all the answers. That mystery is not threat, but invitation. That to not know is to still belong, fully, to the fabric of existence. Sleep, knowing the stars are above you, watching, waiting, whispering in their silence. And know that whatever 3I Atlas truly was, comet, probe, emissary, or dream, it has left us with the same eternal gift, wonder.